back to this class again. I want to talk about definite integral. For definite integral, it's simple. From the word definite, it sounds as if it's a complex statement, but not actually. Definite integral, as far as integration is concerned, is all about getting a value that can be used for analytical operations. So definite integral was invented by Leibniz so as to be able to analyze values that when you bring them together you can create something out of it. Or you say mathematics is the language that the technologists understand. The scientists transfer the language of mathematics to the technologists to build. So by the time you have values that the technologists cannot use, it becomes unimportant to have discoveries and scientific deductions. But by the time you have random values that the technologists can operate on, then science becomes useful. So because of that, we have the definite integrals. So by the time you integrate, for example, if I have a value of, maybe I integrate a value and what I finally get is I get a value to be equals to x cubed over 3 plus 6x plus c. To a technologist, this does not actually make sense. But to me, the scientist, I understand what this means. But the technologist does not understand that. And who is going to build those things for me is the technologist. But the technologist will need values like 106. We need value in units, maybe 78 in units. These are normal values which he can use for his basic operations, plus and minus, within the limits of experimental errors and infinitesimal values. But that's the reason why the definite integral was invented by Leibniz. Probably that should be 17th century or so. I'll have something like this. If, for example, you have a statement like this, you have maybe you have B and you have A, and you have maybe you have x cubed dx. This statement you see out here, this A and B, they are called the definite values. They are the definite values. So this one at the top is called the upper limit. Upper limit. It's a limit. And this one down is the lower limit. So this is what they actually call the definite values. So by the time you express this integral, for example, let's bring this integral out. By the time you express it, you will understand that integrating this will give you something of this nature. X 3 plus 1 over 3 plus 1 plus c, which finally becomes x raised to power 4 divided by 4 plus 6. That's your normal integral. But for you to get an appropriate value for this, you need to have a colib for it. The colib is x4 over 4 plus c. You have at the top the upper limit, which is b, and below you have the lower limit, which is a. So class, you take note of this first. So now we're not going to take questions that have normal values. So remember what I said. The definite value is important for the technologists to build. So you have the A, you have the B as the upper limit, and you have A as the lower limit. So if you integrate a value like this, you have a bound value, a bound range, a bound width. Some of you call it bound width in computer technology, but this is a bound range. The bound range, you have B at the upper limit and A as the lower limit. Good. From here, let's take questions that are numerical. I'll probably use one of your questions. Maybe you have A at the top, you have B somewhere here. Probably not B, maybe Maybe you have something like 3 here. You have something like 2 here. And you have b x dx. Let me say something like this. If you integrate these, what you get from here, this is the upper limit, this is the lower limit. What you get from the integration of these is simple. You just get b as a constant. You have x, 1 plus 1, 1 plus 1, plus c. What you get finally will become bx squared over 2 plus c. But don't forget there's a boundary limit now, which is what? 3 and 2. So if you have that, so you first of all, as a very good student, substitute the value of 3 first. Let's substitute 3. So if you substitute 3, you have b. So anywhere you find the value of x now, replace it with 3. Simple. So what do you have here? You have 3 raised to power 2 over 2 plus c. That's for 3. Minus, let's go for the next bandwidth, which is 2. Let's do that for 2. 2 will give us b, 2 raised to power 2 over 2 plus c. So, since you are not kids, we'll take this. This becomes 9b over 2 plus c. This becomes, 2 here, 1. There's a 2 here, we'll be left with 2. That's 2b minus c. So if you open the bracket with minus, you have minus this, minus that. So this minus cancel this minus. So what will be left with is 9b over 2, 9b over 2 minus 2b. But surely, mathematically, this becomes 2 times 2b. Surely that will be 4b. So 9b minus 4b, that becomes 5b over 2. So, and you know b can be anything. So this is how you do your rough cut. But I'm still going to take another question that will be direct value. So let's try something of this nature. Let's try this. You must understand that the upper limit is the one at the top and the lower limit is the one down. Always remember, the upper limit will be greater than the lower limit. Good. So the reason is because, okay, let's say this. For example, you are having a statement like this. See? Maybe you are having 6x squared minus x squared. Okay, maybe 6x squared minus x squared b plus 2, probably. Then you have dx. At the top here, maybe at the top here you have 3, and at the top here, let's not even say 3, let's say 2. At the down here you have 0. So 2 surely is greater than 0. So because of that, let's start the manipulation. From here, I would integrate this value here. The value here is 6x squared minus x squared plus 2. Integrate it. How do you do that? You take it out. 6 again, you have x, 2 plus 1. The net, what is there? 2 plus 1. Then you have minus, this is x, 2 plus 1. The net, 2 plus 1. What is here? Plus, the differentiation of 2x, 2 is 2x. Plus, don't forget your arbitrary constant, which is the value of c. Beautiful. From there, we can have 6 x cubed, 2 plus 1, that should be 3. And this will give us x, 3, divided by 3, plus 2x, plus c. Now, I have something like this. So, but don't forget that my bandwidth now, my bandwidth value will be at the top is 2 and beneath is 0. So please take a look at this. Take a deep breath and look at this over. 6x cubed 3, x squared 3 plus 2x plus c. Now that's simple enough. We'll continue with the calculation and break down. It's easy for me to say that if 3 go here, we have 2. That becomes 2x cubed minus x cubed over 3 plus 2x plus c. Beautiful. And what do you have here? You have 2 and 0. Good. You have 2 and 0. So if you're having 2 and 0, let's substitute 2 first. Then we'll now subtract that of 0. So substituting 2 here will give us 2 into bracket 2 squared cube, You have 2 raised to power 3 divided by 3 plus 2 plus the value you're having here should be C or so. That's C. Now you have that bandwidth. Minus. The next one is 0. 2. You have 0 raised to power 3. You have minus. Minus. What do I have as minus? So I have 0 raised to power 3. And I have 3 plus 2, 0 plus C. So I have this. It's long. So that of 3 and that of 0. But don't forget, you are always subtracting. Now from here, 2 raised to power 3 surely will be 9. 9 times 2, that's 18. Minus. 2 raised to power 3 is 8. That will be 8 over 3. That is 4 plus C. Now minus. Everything here is 0. 0 raised to power 3 is 0. 2 times 0 is 0. So we have minus 0. We have minus 0. We have minus 0. So this is plus 0. And we have minus C. So minus C plus C. So what we're having here is 18 minus 8 over 3. So every other thing here is gone. Plus 4. So surely 4 plus 18 plus 4. And then that should be 22. Minus 8 over 3. And that will give us 3 times 20. That should be 60. So that should be 62 times 3 times 6. That should be 66. So that will be 6 minus 8 divided by 3. 6 minus 8 divided by 3. We take it out of here. Normally it's supposed to be 60. Actually it will be 58. So 58 over 3 units. So please, you can see that this value, after the integration of this value is this. But this cannot be used by the technologist. But this can be used by the technologist. So that is the reason why we have the definite integral. So, if you're having situations like, maybe you're having codable questions like, maybe you are given to integrate maybe root x plus 4x squared dx. And here you have a minus 1 and you have a minus 3. So if you're having a problem like the minus 1 at the top, minus 3. Remember, upper limit, lower limit. So if you want to integrate this, what do? If you want to integrate this becomes x 1 over 2 plus 1 over 1 over 2 plus 1. You ask me a question. What about, where did the 1 over 2 come from? It's simple. Don't always forget, anytime you have something like this in maths, square root of y. The square root of y also means y raised to power half. That is mathematics. Applying the basic rules of mathematics. Good. But you call that computation. Yeah. So from here, you have plus. Here will be 4, 2 plus 1, 2 plus 1. Then plus c. And also like that. So finally, I'll have 2 times 1 is 2 plus 1. That's 3. So I have x 3 over 2. I have 3 over 2. It's 3 over 2. What we have here is 4x cubed. Probably you have 3. And you have c. So in this course, anything you have here, the value at the top is minus 1. The value beneath is minus 3. So substitute for minus 1 first, you get the value. Substitute for minus 3, you get the value. You take the one of minus 3 out of minus 1. Whatever you get will be the value of the definite integral. So whenever you see that value is like that, at the top, at bottom, those are definite integrals. And they are very simple. But basically, maybe we see another one as a throw. Let's throw this one off. Let's throw this off. So that we will not be bored. Let's throw this off. To throw this off, you have something like integrating values like x cubed. And we have x cubed minus x raised to power 4 probably minus 6x divided by x raised to power 2. So maybe have something like this, maybe dx. Maybe they say that the upper limit, At the upper limit you have 0, at the lower limit you have minus 1. So surely, mathematically 0 is greater than minus 1. Beautiful. So if you look at it, let's integrate it. But before you integrate it, you are going to write it in another form. Writing in another form means this same statement here, this one here, this one. You can write this statement as, you can write this same statement inside this bracket as x raised to power 4 minus 6x divided by x squared. You can divide them in partition. When you partition their division, you have x4 over x squared minus 6x over x squared. So in partitioning them, cutting them off, this for this, this for this. They say what belongs to Caesar, what belongs to God, we just share them off. So after sharing, what do you have here? So you have x squared, we have 2 of it down, we have 4. When you take the 2 out, what will be left? Surely that will be 4 and 2. So you have minus 1 here, you still have x. So here you have 6 over x. But this 6 over x, you can write it to be in the straight or linear form. Complexity of mathematics tells us that that becomes x squared minus 6x raised to power minus 1. Don't forget, anything that is raised to power minus 1, they say reciprocal. Reciprocal means the other side of something. I believe you understand that. So it reverses itself. It reverses a reciprocal. So it shows that if I say GI-RL raised to power minus 1, what it means is that it is 1 over GI-RL and it's equals to BOY. What it means is that the other side of a boy surely will be a girl. Mathematical. So it's not logic, it's just, it's not logic, it's not logic. Probably the cosmologians, they also use that. So this is the expression. Now let's pick this out from here. So that becomes 0, 1, minus 1. What again do you have there? X squared minus 6 raised to power minus 1 dx. So these two values are the same. So if you integrate them, you have 2 plus 1, 2 plus 1. Minus 6x minus 1 plus 1. That's minus 1 plus 1. Then you have the minus 1 plus 1 plus c. That ends up becoming x3, 3, minus, the value here becomes a minus 1 plus 1. Surely that will be 0. Anything raised to power 0 is 1. 6 times 1, that becomes 6. Minus 1 plus 1, that's 0. So automatically, you are having an invalued here plus c. So if you have something like this, what you have at the top there is 0 is greater. The one down is minus 1. So remember, substitute for 0 first, you get a value. You keep that value, substitute for the value of minus 1, you substitute, then you take it out. And what you get, the top minus the bottom. So what you get will give you the definite value of that expression. So class, we've come to the end of definite value, and you already know the importance of definite value now. That's the end of the class. I'm still your math instructor. We'll meet in other classes.